Hello everyone, I am Partha Saha. So today I will be presenting the paper Collaborative Federated Learning Cloud-Based System. This is a joint work with Dr. Naresh Segal and Professor Niad from Purdue University. So these are the agenda for today's presentation. First we'll go with comparison between centralized and decentralized learning, followed by what are the challenges we face in day-to-day life in case of machine learning. Then we'll come up with our proposed technique called collaborative federated learning CFL. So throughout the slides, wherever I'll mention CFL, it means this proposed technique collaborative federated learning. I'll discuss about its benefits, simulation setup that we did the experiments as well as the results, followed by the comparison with classical machine learning techniques, conclusion summary, as well as the future directions that the community can take up with, followed by the final question answer. I can definitely respond to those. With these, I'll first start with what do you mean by centralized and decentralized learning. So in this slide we have two parts. On the left side we see the centralized machine learning architecture, and on the right hand side it's decentralized version, and moreover the decentralized version is the federated learning form of the machine learning. So in centralized case we see there is a central server, the central authority, where multiple parties they need to trust the central authority and need to give away their data to the central server, which gets securely aggregated, and then finally this model, all the parties take leverage of this central model. So in this case the important points is the data that are residing at each of these hosts or institutions, or in healthcare term in hospitals, the data from those hops travel to the central server, whereas the code or the machine learning code stays in the central. So the code within the central server, data travels between from each of these hospitals to the central position. Wherever in the decentralized case, the data stays local. So whatever the private data we want to keep and we want to reside as private, it will be with each of these individual parties or the hospitals or in each of these hops. The code travels in bidirectionally from all of these hops and the central server. So automatically we'll get to know that they are on the left hand side. We need to trust the central authority, where on the right hand side we need not to trust completely, because there is a segregation of the data, private part, which still resides at each of these centers, and the public part of the entire data set can be publicly accessible or can be aggregated at the central position. And again, the federated learning is simply the decentralized version or decentralized variant of classical machine learning. So with this background, let's see what are the problem or the key challenges that we face in machine learning case. So we focus on two important parameters. One is the runtime or performance, and another one is the security. So in centralized case, the security is not that high, because each of these parties need to trust, they need to give their entire data sets for secure aggregation of the performance, as well as the central server takes all the data, execution automatically gets faster. So the runtime is faster and security is low. However, on the decentralized machine learning, that is on federated learning, the performance is slower. It takes time because it is distributed over multiple hospitals or in hubs. However, the security is very high. So that's with these issues of both of the centralized and decentralized, we came up with this part, that is collaborative federated learning, our proposed technique. What we did is that let's first divide the data into two parts. One is the private part In healthcare and in healthcare terminology, it is personal identifiable information PII and personally health information, that all of these, in today's term, nobody wants to share their personal health related information with others because of the various societal norms, or they may face various social stereotypes issues, but they easily can share their publicly available data. So how to divide the data into these sets, as well as uh, this architecture on the right hand side of this slide, we see that the model or the code travels bidirectionally, so that's how these arrows are bidirectional. However, that the data is partial in the sense the entire data set is not being sacrificed. Private data remains private part of the data still resides at each of these hosts. However, on the public data sets is still aggregated on the central cases. So the FL, the federated code still travels between the central as well as each of these hospitals, and the private data stays at each of these cases. Only the public part gets shared. What are the benefits of this approach? Three main benefits. One is that it combines the centralized and decentralized approaches. Second one is that private data stays local, and third one is that balances the runtime or performance, and data is still secured. Now, with this theoretical understanding, we did simulation of our synthetic data sets, and let come up with what we did. Took three entities. A mentions as hospital, B as a drug company, and C is a medical researcher. The time between hospital A to the central server, hospital B to server, and respectively C to server is TDA, TDB, TDC. And for the FL code, or the time for code and the neural network, the weights traveling time from the central server to hospital A, B, C are respectively TPA, TPB, and TPC. The total program execution time we took as TPX, and we assume that there are n number of iterations. In this simulation, we took 30 iterations. Now let's come up with these notations. What are the behavior of centralized and decentralized case? Centralized case mentioned as T1. The total time for all of these cases, it took the time for hospital A to server, B to server, C to server. So we just summed up with n number of program iterations, n times the program runs. However, on the fully decentralized system, we mentioned the time for decentralized case is T2, is the total time of the FL code, as that FL code travels in this case. So FL code from A to server, B to server, and C to server, we just summed up with one time program execution, and the whole thing is multiplied with n times, n number of iterations, and plus 1 is because after aggregating the entire thing, last one time again we iterate, just to keep all the training data set intact. Now we see from these two equations for T1 and equation T2, say that if n becomes very high, automatically T2 dominates, and this happens because in T1 we copy the data only once. However, in T2 the program has to travel in every iteration, so that's why as n gets higher, T2 becomes very high compared to T1. Now with those notations and equations, we took three scenarios: the relation between the program size and the data size. So if the program size is smaller than the data set size, then two things happens. On the left hand side, we took some proportion of the data being shared. So in this case, 50% and 80% of the data being shared. So we see that on the 50% case, the collaborative federated learning, this red colored dotted line, is the middle between the centralized and decentralized. However, on the 80%, if the 80% data being shared, we see that the collaborative federated learning is more towards centralized, and this happens when the program size is very smaller than the data set size. This is for the first case. Moving to the second case, if the program size is bigger than the data set size, then for 50% of the data sharing, CFL is still at the middle between these two cases. However, on the 80% of the cases, CFL is more towards the centralized. And on the third case, when the data set is bigger than the program size, and then we planned to take the behavior of the centralized algorithm as well as the decentralized model, and we see that irrespective of that whether the data set is bigger than the program size or vice versa, there is a constant distance between the centralized and decentralized. However, on the decentralized case, after maybe iteration 1 or 2 iteration, both starts diverging a lot. And with these scenarios, we took a comparison table between the other classical machine learning algorithms for the same parameter, runtime or performance and data security. For centralized cases, we saw that the runtime is higher, data security is lower. For decentralized or federated learning, the runtime is slower, security is very high, and our proposed collaborative federated learning, it balances both runtime as well as security. So what are the key takeaways or the important points that we found from these 3 scenario based experiments? One is that this proposed method takes a balanced approach for performance and security concerns. Second one is that in case of the data sharing situations, the data still gets shared, but the performance, but the privacy is still maintained. It's not the case that the private data gets compromised. And third one is that now the variability or the trade-off we can still control. So if we want to trust the central authority, in case of centralized machine learning, we can give away the entire data. But if we do not trust the central authority, then we can still keep the private part of the data locally and sacrifice the publicly available data set. So that's the trade-off, that which one we want, that high performance or high security. And this CFL, our proposed approach, gives that kind of benefits. Now with this, I come to the conclusion is that the centralized, this collaborative federated learning takes the benefits of centralized machine learning, where the runtime is faster, along with in the decentralized case the security is very high. For the future directions, we took 3 important points, that how we can generalize what portion of the data sets can be private, what portion of the data set can be publicly shared. So need a generalized protocol or the standardized approach for such large data sets, where we can apply this proposed CFL. And before sharing the data, any important parameters or sensitive data can be de-identified. So how to make the generalized approach irrespective of the data sets, type of the data sets, as well as the model. So the generalized, the abstraction or the generalizations of such model and the data set size, data set type, how we can do this de-identification of those identifiable information, so that it will be lossless, as well as we can split the data into private part and public part. So these are the important things that we still plan to take in our future work. And with this, I come to the conclusion of this presentation. If there is any questions, I can definitely take it up. Thank you very much.